Alright, welcome. This is part 2. We're starting with chapter 3 information. And so here we go. Write an equation of a line that passes through 2 points. So the first thing we're going to have to do is actually find a slope, because without a slope we can't find one of our equations. So we're going to use slope formula, which is going to be y2 minus y1 over x2 minus x1. So it's the change in the y's over the change in the x's. It's going to be 13 minus 5 over negative 10 minus a negative 8. So there's 2 negatives on that one. So 13 minus 5 should give us, I believe, 8. 2 negatives make a positive. That's a negative 2. That's going to become negative 4 for our slope. Okay. Well, we have the slope and we have a point. If we have both of those, then we can do point-slope form. And so sorry, that was an awkward break. It's just like I had a bunch of water. Okay. We're going to use point-slope form and plug this guy into here. I'm going to use point x1, y1 and our slope. So instead of y1, we're going to put in 5. Instead of the slope, we're going to put in negative 4. And instead of x1, we're going to put negative 8. Okay, if you look at our answer, it's supposed to be in a y equals form. This becomes positive, so we have to distribute this guy, so that's negative 4x. That's going to be minus 32. And then we just have to add the 5 over, and we're going to get negative 4x and negative 32 plus 5 is going to be a negative 27. Okay, so that's probably one of the most time-inducive problems there. Okay. We can always check it too. Plugging in 5 here, would I get my value of negative 8? Or sorry, if I plug in negative 8 here, I should get a value of 5. If I plug in negative 10 here, I should get a value of 13. Find the slope of the perpendicular line to the line passing through these 2 points. So basically I just have to find the slope and then just do the perpendicular. So that's going to be x1, y1, x2, y2. So I'm going to do negative 3 minus a negative 5. Again, I'm using the slope formula from before right up here. y2 minus y1. And then I'm going to do x2 minus x1. So that's going to become a positive 2 over a negative 4, which is negative 1/2. So perpendicular is the opposite reciprocal slope to this guy. So negative 1/2, the opposite reciprocal of the slope would be 2. Okay. The slope of the line parallel would just be the exact same. So all I have to do is really find the slope of this, and I'm done. So that's negative 5 minus 5. And this is going to be negative 7 minus a negative 2. That becomes positive. So negative 5 minus 5 is negative 10. Not to be confused with 0. Negative 7 plus 2 is a negative 5. Those two become positive 2. And we just keep it the exact same because parallel means the same slope. Write an equation for a line that is parallel and passes through this point. So first things first is I got to find the slope of this line. To do that, we need to solve for y. So I'm going to subtract the 2x from both sides. That will cancel that out. So I get 3y equals negative 2x plus 9. And then divide everything by 3. We get y equals negative 2/3 x plus 3. And so right there is my slope. So we're going to put that as my slope. And we have our point, x1, y1. So I'm going to put this into point-slope form, which is y minus y1 m, which is our slope. That's a 2, sorry. Negative 2 over 3. And then x minus x1, which is 3. Okay, so we're going to distribute this negative 2/3 in, and you're like, oh, this is going to be awful, but not really. This is negative 2/3 x, which is fine. When I multiply negative 2/3 times a negative 3, the 3's are going to cancel. I'm just actually going to end up with a positive 2. When I add the 1 over, I'll get negative 2/3 x plus 3 because of that extra 1 I'm adding over. Okay. If D is perpendicular to E and F is perpendicular to E, what must be true of lines D and F? So this one's pretty easy to draw. So D and here's E, so they're perpendicular. F and E are perpendicular, so F would have to go like this. What must be true about D and F? D and F would be parallel. D is parallel to F. Okay, moving right along. Use the figure to find all the missing values given L is parallel to M and A is parallel to B. So I'm not going to fill in all these numbers, I'm just going to focus on the picture itself. So they only give us one piece of information, but that's okay. It's enough information for me because I know about corresponding angles. So let's take care of all of our corresponding angles first and see how much we can get done. This is in the top right corner of this, so that means 2 is also going to be 26 by corresponding angles. Okay, and I'm only going to look at this at a time. So I can't do anything else by corresponding angles, but if I look at these ones, I can do by corresponding angles now because here's L is my transversal, A and B are parallel, so 2 is in the top right, so is 6, so that's by corresponding angles. And then I can switch over here with B as my transversal and 10 as corresponding angles. So we took care of all of our corresponding angles to get 126. Okay, I could do same side interior, add to 180. So 126 away from 180, that means 3 is 54 degrees. And then we could look over here and say, hey, look at 54 and 8. Those should add up to 180. Or we could say 126 and 8 are alternate interior angles. And so that should work like that. And then we can start filling in the picture really quickly. Vertical angles, so that's 54, that's 126. So basically everything's going to be 54 and 126. 7 vertical angles, that's 54. 12 is vertical angles, 126. And then we also have linear pairs, so 12 and 11 should add to 180, so that's got to be 54 and 54. So everything's 54 and 126. Okay. Number 30, zoom out just a little bit. Solve for the figure below. Solve for x, given A and B are parallel. Okay, so these two, the relationship is same side interior angles. So they're going to add to 180. So 2x minus 42 plus 3x plus 2 equals 180. So it's going to be 5x minus 40 equals 180. 5x equals 220. And let me just do the math real quick on my calculator. 5 goes into that 44 times. And just wanted us to find x, so x is 44. Next one, what is the same problem? What is the relationship here? These are alternate exteriors, so AEA, alternate exterior angles, which are congruent. So we have 8x plus 2 equals 10x minus 34. Subtract the 8x, that becomes 2x. Add the 34, that becomes 36. Divide by 2, I believe that's 18, but always double check. It is, and we're done. X equals 18 with our relationship being alternate exterior angles. Okay, use the figure below. A and B are parallel. Okay, so this one's actually pretty tricky here because our transversal is this guy right here cutting through, and that means this angle and this whole angle are alternate interior angles. So 3x is not equal to 22, but it's actually equal to 22 plus 80. So it's equal to both. So we get 3x equals 102, and then it goes into that 34 times for our final answer. Okay. All right, our next one here is using our theorems to justify if we have parallel lines or not. So I like to look at 1 and 7, so I'm going to cover this part up and say, okay, 1 and 7 are alternate exterior angles. If they're congruent, that would mean that lines A and B would be parallel by the converse of alternate exterior angles. 9 and 11 are congruent, so if I covered this up, 9 and 11 are just vertical angles, so that doesn't prove anything. So I'd say none, justification, none, because it doesn't prove anything. 8 and 9 add to 180, so I'm going to cover this up because I see 8 and 9 right here. 8 and 9 are same side interior, and they're cutting through L and M, so L would be parallel to M. And that would be converse. Again, we proved lines parallel by the converse of, and this time it's same side interior. If you want to prove lines parallel, you got to use the converse of those 4 angle types. Converse of corresponding, alternate exterior, alternate interior, or same side interior. Okay, well, we have skipped chapter 3. We are now in chapter 4, looking at all of our triangles. Okay, explain the differences between each type. Isosceles, equilateral, scalene. I'll just say them real quick. Isosceles, 2 congruent side, 3 congruent side, no congruent side. There we go. What type of triangle has a hypotenuse? That would be a right triangle, and the hypotenuse is right here. It's always across from the 90. What type of angle has a vertex angle? Draw and identify the vertex angle. Well, the vertex angle is going to be on an isosceles, and the vertex angle is the one right between the two. What does CPCTC stand for? That stands for corresponding parts and congruent triangles are congruent. Not going to write that one down. You can write it down. Again, corresponding parts in congruent triangles are congruent. When would you use it in a proof? Once you've proved the triangles are congruent by using one of our shortcuts. So once you prove our triangles are congruent by one of these shortcuts, usually we use CPCTC after that. So if I say the triangles are congruent by side, 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 so I prove 3 sides are congruent, I can now use CPCTC to show any of the corresponding angles are congruent. So usually use CPCTC as a justification to show other parts of the triangle are congruent. Okay, here we have a isosceles triangle. So solve for x and y. So x is going to be the easiest to solve for. These are congruent, so we're just going to set them equal to each other. Bada bing, bada boom. Subtract that over, you get 4x. Add that over, you get 16. So x is going to equal 4. Okay, we didn't have to solve for anything else. We just need to solve for x, and don't have to solve for the side length, so y. This is isosceles. Isosceles has 2 congruent base angles, so those 2 are congruent. That means this is 3y as well. So that means 3y plus 3y plus 2y should equal 180 degrees because it's a triangle, so that's going to be 8y equals 180, and then we just divide that by 8, which goes in imperfectly, which is okay. We get 22.5 for our value of y. Okay, here we go. So solve for x if AED, so I have my finger on E, AD, so this is 2x right here. AEG is 5x minus 2. Well, this one's really easy. These are linear pairs, so they add to 180. Okay, so we get 7x minus 2 equals 180. Add the 2 over, 7x equals 182. And I have no idea how many times that goes in. And wow, it goes in evenly 26 times. That's a 7. It's actually 26 times, okay, which is convenient. Solve for this isosceles. Again, we know our base angles are congruent, so we just set them equal to each other. And this one's going to be really fast. Subtract the 2x over, I get x. Add the 18 over, and I'm done. That was too easy. Okay. Use the figure below to solve this problem. This one's a tricky problem. It's being very sneaky. This is an isosceles triangle. These 2 are congruent. The way I know that is because the 2 base angles are equal. So that's why I know I'm going to set these 2 equal to each other. So 5x minus 8 is equal to 2x plus 10. What a tricky problem. Subtract that over, I get 3x. Add the 8 over, I get 18. X will go into that 6 times. Sneaky, sneaky, sneaky. 44, we have, let me just try something real quick. It looks a little fuzzy. That looks a little bit better. All 3 angles should add to 180. So we get 90 right there with this guy, plus x plus 19, plus 2x plus 11 equals 180. Combine like terms, we get 3x plus, that's going to be 19 and 11 must make 30, plus 90 is 120. Hopefully I did that right. Subtract that, and we get 60, divide by 3, and x equals 20. That sounds pretty accurate, right? Okay, I'm going to double check that math real quick. Always a good thing to do on a test. Yes, 120. And that is 60. Okay, yeah, it works out. So double check your math. Never can be too sure. Okay, this right here. Oh, my computer just died. There it is. It's back. It's alive. It's like you've been talking for too long, and people are bored. Here we can match things up. So here G matches with B. So we're gonna say B goes in the front now. H matches with C, so next would be C, and then the only thing left is A. So that's using the triangle congruency statement. The vertices have to match up in correct order, so if you rewrite it, you have to make sure that they're matching. So G always is matching with B, H is matching with C, and F is matching with A. Okay, believe it or not, we are almost done. I know, that's why I said believe it or not. All right, are these triangles congruent? This was a big problem for a lot of kids on this test. AB is congruent to CD, and AB is also parallel to CD. Okay, and we also have a congruent line here. So I know we have two angles that are, or two sides that are congruent. We have parallel lines, which means these angles are also congruent. So what I have is side angle side. And over here I have side angle side. So I have both side angle sides. So that's going to be by SAS. And A is actually going to match with C. B is going to match with D. And D is going to match with B. So they share both of those. So kind of interesting. All right, and here RC bisects HRT, so these two are congruent. H is congruent to T, so that's congruent, and then they share a common side, so that looks like angle, angle, side. So that's my reason, angle, angle, side. R is going to match with R, T is going to match with H, and C is going to match with C. There it is, RHC. Okay. Chapter 5, relationships, describe the segments and draw a picture. I'm going to tell you to go ahead and reference your notes on this one because it's just going to take a long time to draw them all. And you have notes on all of them. But what I will do is I will connect the ones that go with each other, okay? So let's start with, so these are the 4 types that we have, and they go with one of these 4, okay? So we'll start with altitude, for whatever reason, matches with orthocenter, that's the T matches with the T right there. Perpendicular bisector matches with circumcenter, they both have the R in the 3rd spot. Angle bisector, AN, matches with the IN, the in-center, and then the last one right here is the median, matches with the centroid. Okay, so those guys all match up. All right, boom. Well, 2 problems, that's it. Love it. So the triangle has the vertices -2, 8, 6, -2, 4, -10. Find the slope of the perpendicular bisector of XY. Graph the triangle. Okay. Okay, so we just have to graph or find the slope of the perpendicular bisector of XY. So here's the deal. Here's XZ, so we have -2, 8, and this is X, and Z is 4, -10. Okay, so here's the deal. It's perpendicular, so I just really have to find the slope of these two, and then use the opposite reciprocal. So it's actually not that hard of a problem. You don't even have to fully graph it. So we're going to go back and use the formula we had earlier on this video. And so that's y2, -10 minus 8, and that's going to be 4 minus a -2, so they'll come positive. So we get -18 over 6, which is a -3. So that's the slope of this line right here. From here to here is a slope of -3. So it's perpendicular bisector, which means you have to do the opposite reciprocal. So the slope is going to be the opposite reciprocal of that, which is a positive 1/3. Okay? So, pretty easy. Now we have another triangle. Find the coordinate of A if ZA is a median of X, Y, Z. Okay, so if we have X, Y, Z, let's just draw kind of a generic picture here. It doesn't really matter where they are in the picture at this moment, but ZA is a median. Okay, so if ZA is a median, so median basically goes from the vertex of Z and it cuts X, Y in half. So what I have to do is I just have to find the midpoint of X, Y. That's what I'm really doing. So X is at -2, 8. Y is at 6, negative, or 6, -2. So I'm just going to find the midpoint, and the midpoint formula is pretty easy. It's just x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that'd be a good one for the test. So I'm just going to pick these as my points. So we're going to get -2 plus 6 divided by 2, and we're going to get 8 minus 2, or plus a -2 divided by 2. That's going to become 4 divided by 2, or 2. And this is going to become 6 divided by 2, or 3. So it's going to be 2, 3. It's the coordinate of A. And that's it. We already did chapter 6, so reference the other video to finish off this study guide. And that's it. Good luck. I have nothing else to say.